And the final announcement. After 5 years of co-organizing this meetup, I'm going to be stepping away from it. Next month will be my last month. It's been a great 5 years. I've had a lot of fun helping people start their careers. Had a lot of fun meeting people all throughout the community in Boston and online since we started doing it there. But yeah, it's time for something different. So Zev will be continuing Learn Swift Boston. So keep an eye out on next month's Twitch stream, but also maybe our Twitter, but also maybe our Discord. More announcements to come around this as we're ready to make them. So yeah, with that sad news, let's jump into.
Cool. So this is beginner night, and so we'd like to start you off with sort of the basics, like what even are we doing here? What are the sort of basic moving parts? And the goal is to just give you a sense of like what are the basic pieces of building an app, and hopefully give you some idea of how you could take your app idea and get a little closer to building it. So what are some things called? Where can I find more information? That kind of thing. So the first step is to open Xcode like we have done, and then we're going to click create a new Xcode project. And Xcode is the app that Apple publishes that you use to make iPhone and Mac apps.
You need to request control.
Oh, I thought you were going to do it, but I'm happy to.
Oh yeah, no, I can drive. That's fine.
I'll request anyway in case I need to click stuff.
Okay.
Dog's got to pee sometime.
Mm-hmm.
Okay, cool. And we were chatting just before we went live about what we were going to build. I'm seeing your whole giant screen.
Yes.
Oh, but we can only, that's why they didn't get the sad.png reference, because they can't see the right side of your screen.
Desktop, yeah.
Right. I forgot. Okay. So we were chatting before we went live about what kind of app we're going to build. And what we decided on is a temperature unit converter. We thought it'd be a good way to get a sense of like, how do I throw some stuff up on the screen and do a little bit of math, a little bit of logic to get sort of, some user input, do some things, get some output, and without getting too complex with things like networking, which just opens up lots of cans of worms. And also we have videos on our YouTube, !YT in the chat, if you want to see our sessions on networking. So we're going to build a simple unit converter app where you can put in a number and say whether it's Fahrenheit or Celsius, and it will give you the other one, at least as a starting point. We'll see how far we get, whether we can add a little more. So I'm going to choose, you can choose all different types of platforms. I'm going to choose an iOS app and click next. We're going to call it Converter, unless anybody has a good pun name. And I'm going to choose, don't worry about team unless you're shipping to the App Store. Organization identifier is like usually your website backwards for reasons, but it doesn't really matter much what you put here unless, again, you're shipping to the App Store. For interface, we're going to choose SwiftUI. SwiftUI is the new hotness. Storyboard is the older way of doing iPhone interfaces, so we're going to go with the thing that is more future-facing. And we're going to use a SwiftUI app instead of UIKit app delegate, again, for the same reason that we're going with the more modern stack. Language, Swift is the only choice here, and we're not going to include core data. I actually might include tests so I can do some unit conversion tests. We'll see if we get to that.
Let me take over for this part.
All right.
So once you have gotten through setting up those parts of information, it asks you where you want to save it. And I always forget whether or not I need to make a new folder here, so I always do.
You don't.
I don't.
It will make a folder for you.
And so this is the folder I want to put it in. I forget. Oh, it's not this one. Sorry. I have too many Learn Swift Boston directories on my computer. So we will save it here. I also have the checkbox for create Git repository checked. We might cover a little bit of Git tonight, but it's a good way of managing your source if you work with other people, your source being the code that you've written. It's also just generally good because you get little snapshots in time of things you've done.
Makes it easy to roll back a change if you made a mistake or look at some old version. Also, good stuff going on in the chat. Please feel free to post questions there. We'll try our best to answer them. I think we answered already. Francis Code Elgato 133. Is it with Swift or SwiftUI? So Swift is the language, and SwiftUI is what's called a framework. It's I guess a toolkit would be another word for that. So Swift, the language, gives you your basic structures like variables and if-else statements and strings and integers, sort of the basic building blocks. And then SwiftUI is a framework. It is a set of types and functions that let you build things. So SwiftUI gives you things like views and buttons and text fields. And so it is UI is right in the name. It's for building. It's a tool for building user interfaces. So you can use Swift to build lots of things like networking server stuff that just runs on a server with no interface, and you can use it to build command line applications. But we're building a user-facing app that somebody's going to use, and we're going to use SwiftUI. UIKit is the older way of making interfaces on iPhone, but we're going to use SwiftUI. So keep the questions coming. We'll see what we can do about answering them. All right. So what we've got here is our app is open in Xcode, and over on the left, we have a list of all our files. And on the far left, that's the project navigator. And then we have this sort of split pane here. Left, right?
What? My camera slipped. I was pointing above for the file navigator.
Oh,
the split
you're on the, yep.
Is over here.
Okay, so yeah, so we have our code over here. And then on the right, we have a preview, which will let us sort of view the app as we're building it without having to fully run it. And then there's this panel on the right that you can hide and show with a little button that lets you access some extra attributes and settings and things. We might get into that. I'm going to leave it closed. No, I'll keep it open. Okay, so let's click resume on the preview. Do you want to do this where I talk and you drive, or?
Sure, we can do that.
Okay, so let's click resume on the preview. Because you have to do that to get the app loaded up in the preview. And sometimes Xcode stops your preview and you have to click resume to get it running. Usually when you change anything substantial, it stops the preview. And so you have to click resume, and Option Command P is your friend there. Option Command P for preview to get the preview re-running. So it's going to do a bit of compilation. If you're coming from like JavaScript or one of the web languages, you may not be used to this step, but it has to compile your code before it can run it. But once it's compiled initially, small changes are relatively fast to recompile. So we should be able to see the changes in preview.
With SwiftUI.
With SwiftUI. UIKit, you have to make your change, run the app, make your change, run the app. And we'll do some running the app too, but we'll get started with previews. Maybe. One thing we might try is...
There we go.
Oh, hey, there we go. Okay, cool. So we have our preview, and now we can talk a little bit about the code that they gave us by default. So we have we're in the content view file, and if you look over on the left, there's also a converter app. So we have our app, which doesn't really have anything interesting in it right now. It just puts our content view on the screen, so we don't have to talk about this in detail. Let's go over to content view. And so this is the file that describes what we're seeing on the screen right now, which is the text hello world. And it's in two parts. It has the actual view itself, and then the thing at the bottom, starting on line 17, is the preview. It's the thing that lets you actually see your app over in the side there, and there are stuff you can do to customize previews. So you can add multiple previews, different phone sizes, light mode, dark mode, all that stuff. So that's why the preview is in code, so you can customize it. But we're just going to focus on the part up top. Struct content view. That means this is a structure that is called content view. Colon view means it is a view. It's, the colon means it inherits from the view protocol. which describes a thing that you can put on the screen, more or less. And then every view has a body, and so that's a what's called a computed variable, that var body, and then the curly brace at the end of the line means that whenever something asks for the body, so the system will ask, hey, give me your content so I can draw you. It will run whatever's in the body, and that's going to return some view. And inside, we're making a text that has hello world. So that's a text object that's just going to put text on the screen. And then dot padding is putting some default padding around, which you can see when Matt highlights it, it puts that blue line around it. When you select something in code, it highlights in the preview. When you select something in the preview, it highlights in the code. Pretty cool way to kind of see how your code and your actual visual interface correspond to each other. And if you change the text in there, it'll change pretty much live as you type. So pretty nice way to get immediate feedback, especially when you're designing a user interface. All right, shall we maybe put a button on the screen that makes the text change when you click it?
Sure.
All right. So I think before we put the button, we're going to need somewhere to put it. Right now, there's just one thing on the screen, but if you're going to put more than one thing, you need to describe how the things are positioned relative to each other. So they could be next to each other horizontally, next to each other vertically, various other ways of positioning them. I think to keep things simple, we're going to put the button below the text. So we're going to use what's called a V stack, which is a vertical stack. There's also a horizontal stack or H stack. And the way you do that is you type V stack and you put curly braces, and whatever you put inside those curly braces will show up one after the other vertically stacked on the screen. So we've got our text, and then let's add a button. So we're going to type button, and then if you do an open parenthesis, when you create things, usually you do that with an open parenthesis, and it will show you a bunch of autocompletes for things that you might want to type. And SwiftUI's autocompletes can be a little overwhelming. So until you have a good feeling for which thing you want, it's a good idea to have some reference to look at some existing code on a tutorial or a book or something, just to know, like, what am I shooting for here? Like, which one of these, or does it matter? In this case, you could choose a couple of those and they actually would be the same thing. So it's a little bit overwhelming and confusing. In this case, let's use the action label one. I think that's probably the most straightforward to explain. So this is letting us create a button with some action. So what's it going to do when you click it? And then a label. So what does it look like on the screen? And it actually gives us some nice defaults. The action is an empty set of curly braces, meaning it doesn't do anything right now. So right now it's like a placeholder, but if you double click that or hit return, it'll actually turn it into like real live code. And then it gave us a text with the word button in it, which is actually pretty good default. So if you double click that, it will also turn into real live code. And maybe you could change the text to say hello.
The say hello, or have it
the words say hello.
Gotcha.
So now we have a button that says say hello, and then let's see what happens when we click the button. And right now, if you click, you're just selecting the button in the preview, so that's not really that helpful. Previews are static. They just show sort of the initial state of the view. If you want to be able to interact with the preview, you have to click you either have to run the app or click the little play button up in the corner, which turns on live preview. And that will actually fire up your view inside a real iPhone simulator. And now you're actually running this part of your app. So yeah, we can click the button. You see we get the default sort of press and highlight behavior, but of course, nothing happens. So we need to introduce some state that we can modify. SwiftUI is very strict in how you modify things. If you have a programming background, you might be used to something where in the action, you would maybe go and grab the text label and change its text. That's how you used to do it in the old days on iOS. But in SwiftUI, everything that you change has to be state that you change, and then the view is a function of that state, meaning you've got some variables, you can modify them, and then the view automatically is updated to reflect the value of those variables. So we're going to introduce a variable inside the content view up at the top, like after line 10, that is a special kind of variable called a state variable. So you do that with @state capital S, and then var, let's say message equals, and let's give it a default value of hello stream. And now in our line 14, creating the text, instead of just typing in the string hello stream, we're going to use that variable called message. And you'll see the preview has paused. Like I said, it pauses anytime you do anything sort of large and structural, like adding and removing variables, changing types, that kind of thing. So yeah, we'll click resume. And hopefully nothing will change because we've kept the same value. But now inside that action, the curly braces, we can open up those curly braces and change the message to be something else, like hello Boston. So message equals, and then in quotes, hello Boston. Or internet. Yeah, that's better. Although it is the name of a podcast. Okay. So now when we click say hello, and the text changes. Cool. So we have introduced some state with the state variable, and then we modified it inside the button action. And the most important part here, I think, is line 15, where the value of that text is the value of the message variable. And no matter what message is set to, the text will just display it. So you're not having to go and make sure things stay in sync, make sure once you've updated the variable, you update the label, none of that. SwiftUI is smart enough to see that message has changed and automatically update the display. So that's pretty cool. What should we do next? Should we do text field?
I feel like we could probably jump into the exercise and introduce text field that way.
Okay, so as in let's lay out our interface.
Yeah.
All right. So we're gonna make a unit converter. And let's maybe go just from Fahrenheit to Celsius for starters, and then we can introduce a toggle to do that later. So what do we need? We need probably a text field to type in the temperature. It's probably the easiest way to enter a temperature rather than some kind of picker or something. And so we're gonna have a text field, and then we could either have a button that says, let's go and do the conversion, or we could just have it be live. As you type, if it's a number, live convert it. That might be easier to start with.
Your call.
All right, let's do live. We'll do it live. So so we're gonna make a text field. And when you do your open paren, oh boy, lots of initializers. So there are many different ways to construct a text field. There's sort of, do you care about getting updates when editing changed or when you hit the return key? Do you need to supply a formatter so that the text is constrained to some particular format? We could potentially think about doing that for the numeric input, but we're not going to worry about that right now. So let's find a simple initializer. I think the second one, a title and a binding to a string. I think I always have to try a couple and figure out what we want. So title, I actually am not sure if the title is going to show up if that's only if it were in a form. So let's put temperature in the title as a string and see if it ends up showing up. And then text. So this is a little bit interesting. This is something we haven't talked about. It wants a binding to a string. And a binding is a way that SwiftUI lets you hand a variable off somewhere and say, you're allowed to change this variable, and it will change everywhere. So in this case, we want a string representing what the user has typed in. And we might want to be able to display that somewhere else or use it for, well, we're going to use it for our conversion. So we need a variable to it, and it will also be in the text field. So the way we do that is we'll make a new state variable. So at state var, let's call it maybe user input or typed message or something like that. User input, and then let's default it to the empty string. And then to get so that's a state variable. And to get access to a state variable, to a binding to a state variable, to get access to a binding to a state variable, you got to inflect that right or it doesn't make sense. You need to use the $. So $ user input. So this is a magic variable. When you create a state variable, the $ version is created for you, and it's just a binding of whatever the thing is. So we need a binding to a string. We have a binding to a string. Everybody's happy. And we can get rid of our hello stuff, I guess. Oh yeah, and the button, and we can get rid of our message state var. And let's resume. It's a little weird, confusing, because even though the live preview is running, we still haven't resumed. So yeah, it's weird. Oh, cool. So the title that we put in actually became the hint of the text field. So maybe that should say temperature in degrees Fahrenheit. And it's Shift Option 8 for a degree sign. Or we could do that.
Shift Option 8?
Yep, which is different from Option 0, which gives you an ordinal number 0. It's very strange. Okay. Yeah, that looks good. And then let's have below that, we'll say temperature in degrees Celsius, and then we'll just print out the temperature. So we're going to have a text, and then the string in there. We'll just hard code a string right now and then fill it in with the converted value as we get that working. So temperature in Shift Option 8 degrees Celsius colon, and then just say 1, 2, 3, and then we'll put in we'll put stuff in there later. Okay. And the whole thing, that temperature is kind of hugging the walls a little bit. Let's put on the VStack. Let's put a dot padding after the end of the VStack to inset the whole VStack. Or just inset the text field. That's fine too.
Oh, sorry, the whole VSAC.
Yeah.
I don't know why my brain heard text field. There you
go. Okay, cool. Subtle difference, but now the two things aren't being pushed apart as far. It's also kind of annoying that the one thing is left aligned and the other thing is center aligned, and it's kind of confusing why. But if you mouse over, stop the live preview so you can interact with the like layout of the preview. So if you click on the text field, will it not let you if you've got? Oh yeah, there it is. So you can see the text field stretches to fill the whole width, whereas the text below it always hugs its text size, and that's just sort of a quirk of SwiftUI layout. The easy way to fix it in this case is to go to your VStack and add parentheses after the initial, like VStack parentheses at the top, and do alignment : dot leading, and then delete all the other stuff up to the close paren. Yeah, and that basically makes them all float over to the left. So I think the label is still the same size. Yeah, but it just aligns them all left. Okay, great. So what are we going to do next? We probably need some function. Well, no, we don't need some function yet. What we want to do is figure out what the user typed and use it. So for now, let's make it so that whatever they type, let's just mirror it down below. So if you type 10, it'll say 10, which is wrong, but it'll get us moving. So let's use a feature called string interpolation to interpolate in. It's a backslash. You've been writing too much Ruby. So we're going to interpolate in the user input, and this means take the value of that variable and just splat it into the string there. So if you run the preview now, you should be able to click in the first field and type something, and literally whatever you type will just be reflected in that second label, which is not necessarily that useful, but if you type a number, you should be able to see sort of what we're going for. Okay, so now we need a way to string right now. We need a way to convert it to a number and then do some math and then put it back in the string. I think I don't want to do this math inline, like right right in there inside the view because it's going to get a little cluttered. So what I'd like to do is make a new computed variable. And so let's call this var converted. Converted is actually not bad. Converted input, sure. Another name for converted input is output. So yeah, let's sure. So it'll return a double, which is a kind of number. It's kind of quirky computer science reason that it's called a double, but it's a decimal number, a floating point number. Okay, decimal for the nerds in the audience is not quite correct, but it's a floating point number. And then what we need to do is, yeah, so to get things building, return 1.0, and let's interpolate that into the string instead of user input. So every time the view updates, it will reach into that variable to figure out what value to put there. And right now it's just going to be 1.0. So it's 1.0. And we can worry about formatting in a little bit. Right now we're going to get a lot of decimal points for now. That's okay. All right, so let's see. We need to get a number out of that string. So what we can do is let's make a new variable inside that converted input function. And remember, this is going to run every time the view updates. So we're going to call it input as number, maybe. Yeah, let's do that. And that's going to be a double that we're going to initialize and pass in the user input. And Swift uses a feature called type inference. So Swift is a strongly typed language. That means variables have a type. It's not just a variable. It's a variable of type double, a variable of type string. And Swift is very strict about making sure those match up. So you can't take a string and just assign it to a number or vice versa. All the types have to match up. And if the types don't match up, you'll have to convert them. So, if there's a string, in this case, we want to turn it into a number, we have to be explicit about converting that. And that's because Swift is forcing us to consider, well, okay, I could type literally anything into that text field. I could paste in the complete works of Shakespeare. Not every string is just going to represent a number. So it is forcing us to consider what happens if we type in something that's not a number. So I think in this case, what do we have? Why don't we actually have this converted input return a string, and then we can do all the formatting inside here. I think that might make things a little bit simpler. So let's see. So initialization, right? Okay. So there's a neat Swift trick. If you option click on a variable, it will tell you what type it has inferred it to be. So in this case, it is a double question mark. And that question mark is a signifier that means this is an optional, which means it could be nil. This is a concept where your number could be 1 or 10,000 or pi or -5, but it could also be nil, meaning there's no value there. It's like an empty box. You go in the box and there's nothing there. And this makes sense, right? Because some strings can't be turned into numbers because they don't have numbers in them, or it's got a number with something else. And if your string says 5 bananas, Swift determines that to not be a number. Your string has to be just 5 or 7.2 or something, and then it will turn it into a number. So this is going to give us either a number or nil if it couldn't make a number. And it would be nice if we could handle that and do something special in the case where it's not a number. Fortunately, Swift gives us a way to do this, which is a neat little construct called a conditional binding, I believe it's called. Most people know it as an iflet. So we're going to say, instead of var, well, you can say if var, and then we'll deal with the var in a minute. So an if var, so if var equals that, then curly braces, and then we'll do some stuff in the curly braces, else other curly braces. And so now we have two branches, and the Swift language is going to force us to consider the case where that result of converting user input to a double is nil. So let's actually consider that else case first, and let's say return the string, you must type a number or not a number, or a warning sign emoji or something. I bet that won't fit on the screen. Maybe just say not a number.
Nope, that's not the thing. Isn't it Option Shift? Nope.
What do you want to type?
The thing that brings up the emoji thingy.
Oh, Command Control Space. Nice. Okay. And then in the other case, what are we going to do? So we have our input as a number now. So now we need to convert it to, it is Fahrenheit. We need to convert it to Celsius. So post in the chat if you know the conversion formula of Fahrenheit to Celsius. We'll see if anybody has it. I know there's a 9 and a 5 and a 32, but I can never remember what order they go in. Now I'm waiting for the 5-second delay to see if the chat will update. Celsius equals Fahrenheit. So we subtract 32 and then multiply by 5/9. Yeah. Okay, so it looks like, so like let's say let's stick with var for now. We'll get to let in a second. So var result, or var Celsius. No, var result for reasons. So it's going to be our input as number minus 32. And then we have to multiply it, but we have to multiply that whole quantity. So we need to put that in parentheses. And then times 5/9, which we don't need parentheses for. And then we have our result. And now let's put a new line and do a return string of result. And again, we can think about formatting that later.
My puppy's having a dream and it's really cute.
What? Dog doing cute thing?
He's having a dream.
Oh. Okay, cool. So now we're actually, let's take a moment and look at these yellow things that have been popping up this whole time, because Swift is actually giving us some useful feedback here. Well, first let's try it out and see if it works. And then we'll look at the yellow things. So 32 gave us 0. That seems right. 312. Let's try some other values we know. I happen to know that body temperature 98.6 is about 37 degrees Celsius. There we go. And let's try 212 for boiling. 100. And 32 should be 0. Did you do 32?
Yeah, start with 32.
Cool. Nice. All right. So, hey, we have a sort of minimum viable thing. Can we shorten you must type a number, because right now it's jumping off the screen every time it comes up. So change it to maybe warning, not a number. Yeah, let's see if that works.
Yeah. You must
be a number.
Come on.
You could change it from, you could get rid of temperature in. You could just say degrees Celsius : This is kind of the power of Swift. Oh, yes, very good. Except now, what are we going to say? Enter a number degrees Celsius. Maybe put the degrees Celsius in the result.
Okay.
So it says enter a number, and then you can actually default the user input on line 14 to something else if you want to get a real quick turnaround on your previews, because you don't have to type anything in the app. You can just change the default, like put 32 just for testing. It's not a great practice, but it'll get the job done. Oh, it'll also stop the preview, so never mind. That's annoying. Okay, but at least it's working. Okay, you can delete the 32 now. Okay, so let's look at these yellow things. The one at the bottom is the most straightforward. Will never be executed. We were returning 1.0 before, but now if we get the input as a number, we're returning something else, we're returning something else, and that's it. There are no other options. We're always returning those. So, and return, basically nothing happens after a return. Return is like the last thing that will run in a function, and then it will return. So yeah, we get rid of that. And then the other two are kind of fun. So let's click on the little yellow sign to expand that out. Variable input as a number was never mutated. Consider changing to a let constant. And it's suggesting a fixit, which is to replace var with let. So let's click fix. You'll see what happens. Swift actually has two kinds of variables. There's var, which is variable, and let, which is a constant. Some other languages call it const. Let is from like more of a math background, like let this variable equal this thing, and then such and such. Like I've heard it used in sort of math contexts. So anyway, and then it's going to give us the same thing for the result. We never mutated that result, so we can change it to a let, and then we can be confident in our code that it's never getting changed without us knowing what's going on. I don't know if I did a good job explaining that. I'm going to read the question in the chat real quick. Okay, so we're going to fix this other warning here so that we have lets, and a let is just a nice way to, like, if you don't expect a variable to ever be changed once it's created, make it a let. And in fact, Swift is telling you, is kind of helping you out. And then you can't accidentally change it. Like, just as an example, if you try to assign result to 4, you're going to want an equals there. Oh, that works too. Yeah, if you try to reassign result to something else, you're going to get an error. You cannot do this. So if your intention is to never have it accidentally changed out from under you, then a let will help you do that. And it helps you just avoid whole classes of bugs where a variable gets changed you weren't expecting. All right, cool. So we've got a very basic unit converter for Fahrenheit to Celsius working. Right, this is great. So what can we do to take it to the next level? Yay, we could commit this. This could be our our support Fahrenheit to Celsius conversion. So this will be a nice sort of checkpoint in our Git repository.
Yeah, so Git, if you're not familiar, is a technology that lets you take snapshots of your code over time. And generally, a good coding practice is to use some sort of source control, like Git, to sort of take snapshots of your code when it's in a good state. So right now, we've built this app out to a state that is pretty good. It's got some basic functionality. It achieves our goal, which we're excited about. And so like Zev said, we should probably save this little snapshot in time. And so Xcode comes set up with source control management built in, or you can use terminal if you're confident with that, or you can use other third-party programs like GitUp or SourceTree or Fork. There are many of them. That's just a small list of the many of them. But when using Git, and there are other source controls, you make commits. And so this is taking that snapshot and putting it in the timeline of things. And so if we make a quick commit, we can say...
You want to click on the file to show it's changed?
Yeah. So you can see Xcode does this little render of, on the left is what we currently have, and on the right is what we had at the last snapshot. And so it is showing you that we have added in these comments at the top on this line. We have added in this variable at this line. We have removed this and replaced it with all of that. It's also helpful to give yourself meaningful commit messages. Time and time again, I have seen people just put like arg or like can't get it working or there's more bugs. But it's really good to just say like added functionality to convert user input Fahrenheit to Celsius. Fahrenheit. Have I been spelling it wrong the whole night?
I think it just wants to capitalize
it. Okay. And then down in the bottom left behind Zev's head is, why can't I move this?
You can move the whole window.
Yeah. Is this little commit one file button. It wasn't letting me move the whole window. I don't know why.
Because you'd have to move it from up here.
Yeah. Well, so I clicked commit. If you were quick to notice, there used to be an M here, and now there is no M because the M stands for modified. So if I make another change in the file, you should get a little M back here.
Probably have to either save or leave the file or build something that forces a save. Also, Xcode might be having a grumpy time. There you go.
So we got our M back, and that's just telling me that there are modifications in this file, as well as this blue bar right here, that if I click on it, it can discard the change. It could also show you what the change is if it wasn't just purely additive like that one was. But yeah, there's a whole lot that you can do inside of Xcode to make sure you keep yourself sane. Over the 5 years of doing this meetup, I've seen a lot of people just keep folders of different things that they were trying in their projects. So you'd make whole project copies. This saves you from doing it because we know now we can go back in time to this point where our code is good.
All right. So I was thinking we would add a picker to choose which direction we're converting.
Sure.
But if people in the chat want to suggest other directions to take this, if you have things you would wonder how to add, we can do that too. But let's get started with conversion direction. So when you're trying to do anything, it helps to kind of model the domain to have some structures in the code that you can use to talk about what you're doing rather than just sort of a bunch of functions that call each other. So in this case, we're converting from Fahrenheit to Celsius or Celsius to Fahrenheit. I think it's going to help to have the concepts of Fahrenheit and Celsius as entities in the code that we can have and talk about. So let's create a new type above our content view. And that's going to be an enumeration. So enum, and we'll call it temperature unit, temperature unit. And it's going to have a case for Fahrenheit and a case for Celsius. Maybe later we'll add some more cases. And cases always are lowercase. Sorry, Mr. Fahrenheit.
What is a case?
So a case is a particular value of this type. So think about like an integer is the type, and the value of an integer would be any number from negative whatever to positive whatever. A Boolean has the values yes and no, or true and false, whatever your language is. An enum lets you create your own type with your own values. So temperature unit is a new type that has exactly two possible values. It can either be Fahrenheit or Celsius, nothing else. So, you know, if you were having like a variable that's like which unit to use, and if you were using a number and like 0 meant Fahrenheit and 1 meant Celsius, like sure, you can do that, but you might get confused about which is which. It'd be really hard to sort of read that code and go, this is checking for 1. Does that mean Fahrenheit? Does that mean Celsius? This way, you never have to wonder because you have the actual values. You can see what it means. There's no like indirection. Cool. So now we have a unit. So we should put a way to choose which unit we're going to use. So let's add a picker. Yeah, let's add a picker. above at the top of our VStack. All right, and let's give it a thing. And okay, so what do we have? We have a few things here. So we have one with title key, section, and selection and content, title key, selection, and binding. Those two look very similar.
One's localized,
and then
one's
selection,
not.
label, content. Why are the section label? Oh, I see, because one of them has a label that can be anything. Yeah, let's just use that second one. Actually, the second and first one are basically the same. So title will be unit, I think. I'm fairly sure this one actually won't show up, but let's put it anyway. And then selection. So we need a binding to what we want to select. So like, oh, wait a second. I think we're missing something. How does it know what like what range of values we're picking from?
I think that would be the content, right?
I think no, the content is for rendering. Let's check the documentation. This would be a good excuse to check the documentation, and also I don't remember. So unfortunately, when things are like half filled in, the compiler's like, I don't know what's going on here. So oh, search documentation. I've never clicked that button. You can also get to this window under the window menu or Command Shift 0. But yeah, let's check out the SwiftUI picker. So here they've actually got a good example of they have an enum for flavor for picking vanilla, chocolate, or strawberry. And we'll talk about case iterable and identifiable in a minute, but let's see how they make their picker. So, oh, yeah, you're totally right. Except I think there's a way to create a picker from an array of values that's actually easier. You were right. The content is like you do a for each or you loop through all the things. I thought there was a more compact way to do it, but I guess not. Okay. So the selection will be a binding to a variable representing a temperature unit. So we'll do a state var unit equals, let's default to temperature unit dot Fahrenheit. Oh, this should be, is it like, does it mean from or to? Let's say from unit. Instead of just unit. Theoretically, we would have, from unit and to unit. So maybe we could add that later. Okay, so we should be able to give it a $ from unit for the selection. And then content, we should be able to hit return on that and it'll autocomplete to a bit of a nicer structure. Yeah, so here we need to put in some content. And hang on a second. Or, well, we should Google this on your machine so people can see it. I swear there's a way to give a picker a list of things and it automatically does the list stuff. Can we try like SwiftUI picker array? Any one of those first few should do it. Usually can't go wrong with hacking with Swift or Swift by Sundell. Okay, so this one uses a for each. I might just be totally making stuff up. I might be thinking of list or something. Yep, that uses a for each. That one lists them out fully.
Yeah.
Yep, they're all using for each. Okay. And we shall use a for each. I mean,
What
since
is
we've only
a
got
for
two.
each?
So a for each is a view, which is definitely unexpected if you're used to other programming languages. If you're not, don't worry about it. A for each takes a list or collection or array of items and then gives them to you one by one and says, here, give me a view for this next item. So it's a way that it lets you construct views for a whole list of things. And in this case, I think we want, yeah, that first one should be good. So data, so we need to give it an array of these temperature units. And there's actually a neat way that we can get that for free from the Swift language. So if you go up to temperature unit, the enum, and conform it to a protocol called case iterable.
What is an array?
An array is a list of items. There are more detailed answers I could give, but that should be enough to be getting on with. Yeah, so case iterable gives us sort of a magic variable called all cases that will be an array of Fahrenheit and Celsius. And then if we add another case, it will just become part of that array. We won't have to go and update anything later. It's always nice when you can build something the first time and know that it will be correct even if something later changes. So yeah, we can go to temperature unit dot all cases, lowercase a, because uppercase a is a different thing. And then the content. So we're going to be given unit in, and then what this syntax means, unit in, is like, so we're going to loop over all the cases, and then inside the curly braces, it's going to give us each unit in turn, and we're going to call it unit just inside those braces, and then we can do something with it. And in this case, we want to make a text of that unit. And we're going to have to do a couple things to clean this up because I don't think it will compile right off. And in fact, it is so not compiling that Swift is saying, I failed to produce even a diagnostic expression. It's so wrong that Swift doesn't even know how to help us. And unfortunately, SwiftUI is young enough that happens more than we would like. This is like a very common setup for, I'm trying to learn how to use pickers and I did a couple things wrong, but like, come on, help me out here. I'm pretty sure I know what's going wrong, so we should be able to get this fixed up, but just be aware that, yeah, that's going to happen. So I believe one of the issues that's wrong here is that to use for each, you either need to provide a way for the items to uniquely identify themselves, or you need to conform the enum to a protocol called identifiable. And we're going to do that one. So identifiable basically promises that you will provide an identifier that that uniquely identifies each case. And I think if we have temperature unit be an int, like temperature unit : int, or actually make it string, because then we'll get a string value for free, then I think we'll either get identifiable or we'll need to provide it. Okay, yeah, so let's provide it. Click fix. Var ID, so instead of object identifier, let's change that to string. And then in curly braces, return self dot raw value. We don't need a string interpolator because it's already a string. And you can even shorten that to just raw value because the return and the self dot are both implicit. What? Oh, yeah, not return dot raw value because that'll think you mean string dot raw value. But if you get rid of both, then you can. Yeah, cool. And let's move that below the cases. Just, oh, what? Okay. Apparently I'm wrong. Why am I wrong? It should totally work. Okay, and then cool. So that's great. And then unit, instead of interpolating it in, you can do a unit dot raw value instead of a string. Yeah, because a unit dot raw value is a string. So let me back up a second. So when we set our enum conform to string, that means that each case automatically gets a special backing string that is just the name that we gave it. So we get the raw value, and then let's throw a dot capitalized on after the raw value. And that'll give us a nice user facing. I mean, maybe not the best way to do it for various reasons like localization and stuff, but it'll be good enough for this. Yeah, let's resume the preview. I bet this will look wrong because I bet we have to change the picker style. Oh, hey, look, we've got something. So that's one of those little like Tumblr style pickers. Not the most graceful way to pick two values. So let's improve that slightly by going after the picker and doing dot picker style and do segmented picker style. This is the one place I think, so it's not a dot, it's a just uppercase segmented picker style. This is the one place where using the beta would have been nice because you can do dot segmented because they changed how protocol stuff works in Swift, and you have to construct it with parentheses.
Oh yeah. I understand what's happening.
Which is another really confusing. Like why? There we go. And we don't have a selection, and I believe that's because we need to use a tag, and I don't remember how to like what you're supposed to do there. And I swear there's a easier way to do this. Yeah, they're tagging them, but if you look at the later examples, I feel like they didn't use a tag. Maybe go back to the open in developer documentation at the bottom. I swear they had an example. How to access Discord server. I'm so glad you asked. Links.
Also, exclamation point Discord.
Discord. There you go. There's a link to join the Discord. Okay. Scroll on down. I feel like the one that used a for each. Yeah, look at that. Totally didn't use. Wait. On the other hand, tag. Okay, so if the selection type doesn't match the input to for each, you need to provide an explicit tag. So are they saying that previous code sample doesn't work? The one above this one?
Yeah.
To provide a selection without explicitly listing each option, you can create a for each. And then does it say, but this doesn't work in the next, like I'm looking, do I have control still?
Yeah,
cool. So I was looking here, like this is basically what we have, right? We're iterating over all cases. We get our
so it says in this case for each automatically assigns a tag to the selection views using each option's ID.
Yeah, because we're identifiable. Okay, so then why they're even capitalizing them? So why don't we have a selection? What if we select something? Doesn't stick? What if we run this in the simulator?
Yeah, I was gonna say maybe it's the preview and we need to run it properly.
So I hit Command R or click this little play button here, which will launch the iPhone simulator and run our app. So simulator is a little more full featured. You can do some hardware stuff like keyboards and rotation, and it's got a home button. So you'll use that for your real app testing. Previews are nice for sort of stepping out an interface. Previews are also usually faster.
Remind myself and the future self to edit that out.
Yep. Cool. We still don't have a selection. We should probably Google why. Like SwiftUI picker selection not working. I don't think it's not. Actually, let's find out. Let's go back real quick and like put a label in the view to test whether the selection is actually sticking. Let's just add a debugging label after the, like somewhere, current unit. From unit dot raw value, because otherwise it doesn't know how to turn it into a string. Huh. Yeah, it's totally not letting us change the value. So yeah, can we go back and Google?
I'm gonna try simulator right quick before we do.
Sure.
Yeah.
Maybe we do need the tag. Didn't work for me until I added tag for text.
Can do.
I'm seeing a bunch of results. It's not working. I swear I've built this exact thing. This is what it's like, folks. So what a lot of people are doing is doing a text, and then they're using they're basically iterating over the indices instead of the actual values. And wait, so Apple is using a tag?
They are.
But they have a tag on the for each version as well.
But they're using a variable that's inside of. So they're using the flavor raw value, which would be. What? What is even flavor? Flavor is an extension of flavor. What is flavor?
I think they do. Yeah, they define flavor at the top. Yep, they ID string return self.raw value, which gives us a separate value for each thing.
And
it is weird that they're tagging it with the suggested topic.
Yeah.
Seems unnecessarily complex.
Oh, it's not a raw value that they're tagging it with. I'm just tagging it with.
Oh, it's the value itself. Yeah. Oh, that makes a lot of sense.
There you go. And all of a sudden,
I still hate that you have to tag it. There's got to be a way to do it without tagging. But okay, onward and upward. Yay. Okay, you can get rid of that debugging label now.
Sure.
Well, that was fun. Okay. Cool. So we have our picker, and now we need to make it do stuff. So, all right, let's just start knocking out parts of the app that are wrong. Right off, temperature in degrees Fahrenheit needs to be temperature in something else. So maybe like line 37, we want to be able to put in the unit dynamically from whatever selected. So why don't we add a getter, add a var to the enum that is like unit suffix, unit, something like that.
Instead of another variable, why don't we introduce the concept of a function?
Ooh, let's do it. I like it. So yeah, let's do a function. So func.
And then what is a function?
A function is a thing that has a name, and you can call it and you can pass it some values, and it will do some work and give you back a value. Maybe instead of toSymbol, should we say format?
Sure. I think you and I have something different in mind.
Yes. Oh, yeah. I was going to have it take a number and append, or, like, how dollar signs and cent signs like go before and after. Sure. Like, I don't know what else is up with different unit symbols. So let's just say format. It will take as input a number and return, or as input a number and return back a string. Maybe as a double, because we're dealing with doubles elsewhere. We can talk about prettifying it later. And so we're gonna interpolate into a string. Oh, but let's switch on self.
What is a switch?
So what is a switch? Switch is it's kind of like an if, except it knows about enums. It knows that they have specific cases, and it lets you match against those cases. And it's very strict. So if you leave out a case, it will fail to compile. It will say, hey, I have to, if you try to compile this in a second, Xcode will say, switch must be exhaustive. Switch which must be exhaustive, and it will even put in the new case for you. And autocomplete in new Xcode is even better. It will autocomplete them all right from the start. Okay, cool. So we can do return number $F and number $C. Oh, now that we've done that, I realize why you wanted to do it the other way, because we're not formatting a number in that first case. We're just saying temperature in degrees Fahrenheit. So let's do it your way, where we just return the symbol. And then we don't need to take a number. Yeah, exactly. Yeah. If you're wondering why a function, not a variable, they're basically equivalent if you don't have any parameters. And actually, if you don't have parameters, I would usually use a variable instead. But it's nice to introduce the idea of a function. Okay. So now as we change the picker, cool. So we get that changing. And now if we go down further, we're going to need to change the conversion code and the result formatting. Okay, so why don't we do this? Let's do let result : double and then not assign it to anything.
What?
And then set the result inside a switch statement and then return it.
Where here?
So line 55. Yep. Let's put all the conversion stuff down a line. And we're going to say let result : double and not assign it to anything yet. And Swift is pretty clever because even though we have made a let, which is, remember, is a constant, as long as we only assign it once on any given code path, it'll be happy. So we can switch on from unit. What I like to do is delete all the cases and defaults and everything, and then wait for the error and let Swift fill it in. But again, Xcode 13 will just autocomplete it right the first time. So now we can do, we already have the Fahrenheit one. So let's set result equals the result of that in the Fahrenheit case. And then in this one, we're going to have to do the opposite in Celsius case. So I believe it's going to be 9/5 and then add 32. So you can't, you just got to turn inside out as well as upside down. So input number times 9/5. So flip around 5/9 to 9/5 and then add 32. Yeah. So
should it be multiplied by it or divided by it?
Well, it's either divide by 5/9 or times 9/5.
Times 9. I got you. I understand.
So yeah, it's like I feel like this is an underappreciated feature of Swift, that we made a let and then oh, hang on. Let's can you control I select that switch statement and hit control I? That will auto indent. Oh, really? Is that the indentation?
It's the correct one.
Heck, I thought the cases. Do you have a setting change so your cases get indented?
No.
Aren't cases not indented
usually
by default? I'm confused. Okay.
In fact, I've changed something on this line, so control I is working. Maybe they finally fixed it so the cases are indented.
No, cases shouldn't be indented. They don't represent an extra level of control flow. Anyway, cool. So we've done that, and then we need to throw in the from unit.to symbol on the thank you. The result is fine, and then yeah, the unit.
We did do the degree, yeah. So
here's a cool trick. If you do backslash and both parentheses, then you can use autocomplete inside the parentheses. All right. So let's try some stuff. So let's enter some known values, 212. Oh, the preview crashed. Oh, because you're typing when in there for some reason.
What a jerk.
It's continuing to do it.
All right, we're gonna run it in the simulator.
Yeah. Something broke in the code.
Yep.
Ooh, fancy. You get the keyboard in the simulator. And then it goes away again.
What is happening?
Simulators.
What actually just happened? So this is a crash. If you've never experienced one.
Hit continue.
Yeah, I'm pretty sure it crashed.
Do you have a breakpoint on?
Nope.
Yep. CXA throw. That's what was hitting. Something in Apple's code was throwing some internal error, and you were just getting caught in the crossfire. So you can still use your hardware keyboard as well, if you want. Oh, that's cool. Yeah. So whatever number you put in, it will convert both ways from whatever it is. Cool. All right. So we've added Celsius support. Oh yeah, negative numbers. We hadn't tested with those. Why don't you input, like, go to Celsius? No, go to Celsius and do like -20.
Something's wrong. I have Celsius selected. Oh, so then I have Fahrenheit in here. Do we have this backwards?
We sure might. Input is Fahrenheit. Well, let's do a known value. So put in 0 Celsius.
I think we have
32 Celsius is 89 Celsius. 32. Yeah, something's wrong.
This is inverted.
I don't think. Wait, can you go back to the app and put in some known values?
So hold on. So we're selecting Fahrenheit, and that is saying we're turning Fahrenheit into Celsius. So, but here we're turning Fahrenheit back. So this should be the opposite case.
Yeah. So there's an implicit notion here that we only have 2 temperatures scales, and we're converting between them.
Yes.
Right. So if you're in Fahrenheit, you're converting to Celsius, and if you're Celsius, you're converting to Fahrenheit. What might make sense now, just in terms of design, is to add, from unit and to unit.
Sure.
And then we can start to get a little, have a little fun with some types. Oh yeah, JoeCab15, try converting 20 Celsius and 21 Celsius, just like Apple supposedly tried to do. Yeah, so people were reporting that prior to iOS 15, the iOS weather app would not show 69 degrees. And there were all sorts of conspiracy theories about, like, is it because they, kind of want to keep it clean? Or is it because Celsius degrees are almost twice as big as Fahrenheit degrees? And so it's possible that in conversion, there's a rounding error and it's basically skipping a number. And that seems like it's probably what it is. But also in iOS 15, it is apparently capable of displaying 69 degrees.
Yeah, it's probably just someone messed up some math somewhere.
Yeah. So, okay. Yeah. So, okay, great. From unit. Oh, that's interesting. You put them in an H stack. Cool. Although I was thinking it might be nice to add Rankine at some point, or Kelvin, and then we might run out of room. But that's okay. We can shorten them to just symbols instead of full words. Why don't we default 2 unit to Celsius? Unit, all cases. Yep, that looks good. So now we have some.
It didn't select this by default.
It's not running.
There you
Cool. So we kind of have a choice to make in terms of how to build this next part, because now it could be any from unit to any to unit. And what we could do is switch over all the froms and tos, and if they're the same, return the same number. We don't have to do any conversion. But then we have to write a whole bunch of switch statements. Another way to do this could be convert everything to kelvins and convert everything back from Kelvin. So whatever the conversion is, you have a to Kelvin and a from Kelvin for each unit. I don't know which I prefer, but as we start adding more, or to Celsius, it doesn't matter what the currency type is as long as you decide on one and you're consistent. What are you thinking? And chat, what are you thinking?
This one broke my brain just now.
All right. So what I'd really love to be able to do is move all the conversion logic to the temperature unit type, so that down here we can just say from unit dot convert number to unit, and and sometimes I like to do that. Like I like to think what's the line of code that I want to be able to write, and then back solve to what would I need to do to get there. So what I would love to be able to do is
we could introduce the concept of a tuple or tuple.
Convert input as number to unit. So yeah, this would do a conversion where presumably under the hood, it would, whatever it has as input, convert it to kelvins, and then or whatever, probably Celsius actually, and then whatever the to unit is, convert from that to the to unit. So then we don't have to write a conversion from every type to every other type, because as we add types, we explode out exponentially the number of conversions we have to do. Instead, we convert them all to one central type. It doesn't really matter which one, and then convert back to whatever the output is. Make sense?
Yeah, okay.
Do you want me to type it, or you want to do it?
No, yeah, I got it.
Cool. So yeah, why don't you copy my my chicken scratching as a starting point, and then we'll sort of backfill in whatever we need to actually make it work. So let's fix up the types. So to is going to be a temperature unit, and you'll notice Matt added 2 names to that second parameter, and that input as number can just be input, and even and we'll put an underscore, and then I'll explain what both of those mean. And there are some thoughts in the chat about the units. We'll look at that in a second. So just do underscore and then just call that input. We know it's a number. So 2 interesting things about functions here. We have given this function, we've given this parameter 2 names, an inside name and an outside name. This is the outside name, and it lets the function read naturally like an English sentence. So convert input as number to unit. I mean, the two is a little awkward, but it lets us naturally put in connecting words like to, because in context of where you're calling the function, it makes sense to have the word to there. But it wouldn't make sense, or it wouldn't make as much sense to have a variable called to inside this function. So we get to give it another name, and this is the name that will be used inside the function, which is very convenient. And then in this case, we use an underscore, and that underscore means we can omit the name, because it's obvious that the first parameter is the thing that we're converting. So we don't need another name. Okay. So yeah, let's go ahead and stub that in. Okay, so Allegor44 in the chat says, I think kelvins might be more accurate, so maybe that should be the base unit. That's interesting. Yeah, maybe based on like, floating point conversion and stuff, maybe. I mean, it makes sense to have Kelvin be the base unit anyway. It kind of is the standard base unit. So we're just going to need a bunch of formulas for, yeah, everything to Kelvin and everything from Kelvin, which should be pretty straightforward. But I don't want to do all these conversions in here.
Yeah,
I would
I
like
was
to do them.
that.
Okay, you're grabbing them all. Great,
Yeah.
good idea.
Okay.
Would you mind labeling them with what you searched for? Because otherwise it's going to be hard to necessarily figure out which is which. And the other one is Fahrenheit to Kelvin. Oh no, the other one's Celsius to Kelvin. I recognize that one.
Backwards, but yeah.
Backwards? Yeah,
it's
okay.
Kelvin to Celsius.
0 kelvins. That's not right. No, that top one is Celsius to Kelvin. I don't know what they're talking about, but yeah, because 0 kelvins, you can't take 0 kelvins and minus anything.
That's what they're saying. They're saying that Celsius is 237.15 below Kelvin.
Yeah.
If we made this 0, there should be 273.15.
I know, but the thing at the bottom is confusing. That's okay. We know what it means. We can put in some testing numbers.
Okay. Where would you like these?
So what I was thinking is we would put add a function for let's see. Yeah, so let's add a new function. We'll add two utility functions. We'll add a to Kelvin and from Kelvin, and then we'll put them together as building blocks inside that conversion function. So let's see. We need to take a number as input because the values we're calling these on are not temperatures, they're just units. So we need to do to Kelvin of a number and from Kelvin of a number. So 2 Kelvin temperature value number's fine. Except 2 Kelvin from what? How do we? Oh, right, it's self. Yeah, we know what unit we are. So we're basically saying the value as input, we're assuming it's the current temperature unit and converting to this other unit. So let's put a switch in each one of those. Let's just do the first one first. And yeah, switch on self. If we're Fahrenheit, we'll convert to Kelvin somehow. If we're Celsius, convert to Kelvin somehow. And then we'll add Kelvin support and it'll be really fun because it'll be easy. Okay, so Celsius is the easy one. We know we just have to take, if we are a number Celsius, to convert to Kelvin, if we're 0 Celsius, that's 273 Kelvin. So we need to add 273.15. And then for Fahrenheit, it's going to be something about 273, 9/5, and 32, but I don't trust the Google ones.
It's converting it to Celsius.
And can we get a Fahrenheit to Kelvin conversion that didn't come from the Google automatic algorithm of strangeness?
It's doing this plus 273.
Oh yeah, the reason for that is that Celsius degrees and kelvins are the same size. They're just shifted. So the scaling factor is going to be the same. But I would feel more confident if we got testing values from somewhere else.
This one. It's doing that.
That's definitely maybe not right or maybe right. one of those. We'll try out some known numbers and see what happens.
That matches that for
and
me.
I know, I'm sure if Sean is on the call, he's screaming that we should be writing some unit tests. And you know what? You're right.
Kelvin to Fahrenheit. This is 2 Kelvin, so we'd want to do plus here.
That's backwards.
Yeah, so I had to write the first time.
But you can't, the 273.15 can't be in the same brackets as number, because number is Fahrenheit and 273.15 is a Kelvin's, right? We need the formula written out in not sketchy Google. Very good. No, don't use that one. It's too confusing. Just use how to convert Fahrenheit to Kelvin from ThoughtCo at the bottom. There you go.
Oh, this is something I can't copy paste though. No.
Yep.
Plus 459.
Yep.
All right.
That's basically, it's pre-done the conversion, and it's incorporated the 32 and the 273.
There you go.
And that X is, yeah.
There you go.
Okay. So that's 2 Kelvin. And then from Kelvin, we're going to reverse those. So you can just copy and paste that and then reverse the thing. So the Celsius is easy. No, those stay the same. Celsius subtract 273.15. And this one, you're gonna have to swap the 9/5 and the minus. So the 9/5 goes inside because it is a scale factor, and the other thing goes outside because it's already in Fahrenheit. Yeah, I believe that's correct.
Math. Oh wait, we haven't
okay.
done anything with it yet.
And now let's piece together our pieces in our convert function. So we're going to say, we're going to convert 2 Kelvins and then convert to the resulting unit. So let's do let Kelvins equals self dot 2 Kelvin, the input, and then let output equals 2 unit dot from Kelvin. And put in the Kelvins. And let's have this one return a double just to do a straight numeric conversion. And then we can do the formatting elsewhere. So you can get rid of you can just return the output. Okay, so we should be able to plug that function in and simplify our stuff down there. Yeah, so basically uncomment let result equals. And then comment out the switch and the let result below it and everything. And then it should work. And we'll see if those codes were worth the price we paid. Yes. No, that's still right. 2 unit. Yes. Right. That was the whole point of what we were trying to fix from the first place.
Kiazi, thank you for your Prime subscription. Really appreciate it. So let's do what we already know from Fahrenheit to Celsius. So 32 could be 0. And then we'll change that and that. Basically the same thing.
Yeah, that's you're gonna get some floating point rounding errors. So we will eventually use a number formatter to do the right thing there. Yeah, and okay, let's do a number formatter now because obviously it's gross. So I believe there's a way to do number formatting.
Hold on. What have we done?
What? That's 0. Fahrenheit, that minus 5.6 times 10 to the minus 14 is 0.
So this is an interesting thing to be aware of, which is floating point math is not always accurate on computers.
Yeah.
So this is an impossibly small number that is basically 0, because, you know, if you remember back to school, you're moving e minus 14, so this decimal point is really like 14 places over here.
Yeah.
So it is an incredibly 0 number without being 0, because computers can't do math well.
Yeah. It's I mean, we have the same problem in decimal. We just don't usually think about it. Like, you can't represent 1/3 in decimal. It's 0.3333 off into infinity. But if you have a limited number of digits, you have to stop somewhere, and then it's not 1/3. It's, you know, a number of digits. And in computers, you have a limited number of digits, and it's binary. So the problems are not at the same like stopping points as in decimal. But yeah, you're gonna run into that. So it's a good lesson in, you should never display raw numbers to users. You should always format them. And I think there's a quick way to do a number formatting in the string interpolation. I think you can supply a formatter. Like, I think, can I try something?
Do it.
I think I remember seeing that you could go formatter like that. Oh,
Because
how do you
this
do
is
it?
a string, not a text.
Oh, oh, that's unfortunate. Yes. So we could either have this return a double and convert it elsewhere. It's actually not the worst idea.
We lose our 2 symbols, so we'd have to move
we would
that.
lose our 2 symbol. Okay.
Yeah.
Yeah. So we could put it here, but then we lose this thing. So we would have to put this in the view instead, which we could do. But for now, let's just do, I'm going to be lazy-ish and do.
Can you put a text in a text?
Ish, but not with
That's fine. That's fine. Do what you're thinking.
Yeah, I'm too tired to answer that question. Okay, this is pretty gross. There's a little bit of like cruft here. I'm hoping that this will get cleaner in sort of coming versions. Let's break this out into a variable. Let's do let formatted number equals all of this. And it's going to give us an optional string because for some reason, some numbers can't be turned into strings. I'm actually not sure why that would ever fail. I feel like that's there for legacy reasons. So I'm going to do what is sometimes considered a no-no, use an exclamation point to say, if this ever does come out nil, please crash. And we'll, you know, if that happens, we can deal with it, but I'm not expecting it to happen. So I've made a number formatter and I've asked it to please format the result. And I have to convert it to NS number because number formatter is an old school thing that expects numbers in old school ways. I think they cleaned up the formatters this year in the new stuff. So this would be a lot nicer if we were using iOS 15.
You can also clean it up a bit by having multiple if let values.
Yeah.
Boop, boop.
Cool. So it's nice to check that Fahrenheit to Fahrenheit, the number doesn't change, although we do have a -0 there, which is another quirk of floating point. Like, -0 doesn't have a meaning mathematically, but because of the way computers store numbers, like there's one bit of the number is reserved as the sign bit. And so you can end up with 0 and -0. And I feel like we don't need to deal with that right now, but it's another thing to be aware of. Good thinking.
So if you don't want to use exclamation points because exclamation points can crash your app if you're not careful, you can instead do multiple if lets, separating them with commas along the way. And so
Good
that
thinking.
should safely.
You just have oh, that one isn't
Yeah.
optional, so you can do caselet in front of it.
Oh.
And it's just a weird little trick that makes it work. It's one of those Swift syntax things that basically doesn't make any sense. It makes sense if you look at some more advanced cases, and it's like, oh yeah, I can see why that exists. And then this is like a degenerate case of that, where there's no reason it should be caselet, but it is for reasons. You don't need result anymore. That goes away. Sweet.
Super concise code.
Yeah.
I've always known about caselet, but I can never ever remember how to use it. So I'm glad that you remembered.
Yep. If you need to jam a non-optional in the middle of an optional chain like that, that's the way to do it. Okay. So now we've added Fahrenheit and Celsius. Like you can choose the from and the to. Cool. Cool.
Well, that pretty much actually gets us to time, though.
Yeah.
So I think a good way to end this is by committing it.
Let's commit it, and then if you wouldn't mind converting to adding a conversion to Kelvin, I think it will be like 30 seconds and be a really satisfying button on the end.
It'd be satisfying, but it's also a great exercise for people watching at home to try out.
Even
and if
better.
you run into any trouble, you can join our Discord channel and we'll help you out, because it should be pretty simple to do.
That's why I'm sad to be losing you as a co-host.
I promise you it's not driven by how tired I am. It is actually
and for extra
suggesting it's a good thing for people to try out.
For extra bonus points, yeah, so we should commit this as like add bidirectional conversion or something like that. For extra bonus points, go and learn what the Rankine scale is. That's Rankine. I'll put it in the chat. And add conversion for Rankine as well. The temperature scale they don't want you to know about. And we will push up this code to our GitHub. Yes. Which, do we have a link for that in the chat?
No, but I always add it to our YouTube videos, and I will make this YouTube video quicker than I normally do. So if you go over to our YouTube channel, !YT in the chat, you can get a link to our YouTube channel where you can find this video without all of the waiting for the simulator to pop up, as well as a link to our GitHub where I will host this code.
Yeah, so if you weren't following along, you can download it and try adding stuff.
Ability to convert to Rankine scale.
Yep.
Yeah, so once I add a remote, I will be able to push to it, and I will try to get this video edited Sunday. No promises. I'll get it edited as quick as I can. Keep an eye out on our YouTube channel for when that goes live.
Cool. Throw us any questions in the Discord. Oh, I just noticed, speaking of 273 degrees, I have 273 unread emails.
What a nice...
Hey, that's 0 in Kelvin.
There you go. Basically empty inbox. Yeah, so I had a lot of fun tonight. I don't know about you, Zev. I also learned a little bit, which is great. It's amazing to me that, you know, I've been doing Swift programming for 6 years, however long Swift is old, and I learn something every time we do one of these meetups.
Same.
So
pickers, you gotta add tags.
Yeah, and caselet, you gotta remember that that exists if you want to not have optional things in the middle of your iflets. So I call that out specifically because, like, I've always learned in these things, but also as you're starting out your journey learning Swift, you might be discouraged or disparaged by your struggles. You saw two people that have been doing iOS development collectively for about 20 years, struggle tonight. We had to use Google. We had to check blog posts, documentation. We had no idea what we were doing at one point. My brain completely broke when we were converting all the things around. So cut yourself some slack as you're trying to learn anything, but specifically Swift and iOS development. There's a lot to learn, and you never stop learning. So I hope that inspires you to go out and add Rankine and Kelvin, or come up with your own ideas and ask plenty of questions in our Discord. Thank you so much for watching, and we'll see you next month.